And this year, I found some people that do some work. And they dress themselves up a little, but actually they're not doing any work right now. They're just dressed up in bunny suits. And when we come back, we're going to dress up in a bunny suit ourselves and go into this room right here, which is 10,000 times cleaner than a hospital, and make these little modules right here.
Well, you know, it's almost Easter. It's the time to dress up in a little bunny suit.
It's the time to dress up, isn't it?
Yes, Bob?
Those are called chips, right?
Yep.
So this segment's kind of a chips and a dip. Go ahead.
There were some aspects to my long weekend that were very enjoyable.
In Fayetteville, Arkansas. What's on the front page today, Phil?
Better yet,
Well, this is on the front page of the morning news of Northwest Arkansas, and the big news, it just won't go away, the fact that Arkansas University, their basketball team, are in the Final Four. They were the winners last year, and you know what? People are jumping on the whole opportunity here of making a lot of money, and they're illegally printing up T-shirts. They're selling like hotcakes, as they say here in Arkansas, or as biscuits, as they would say in the South here. And this is the big news. It just won't go away. I've been told it's bigger than a sport. It really is quite a religion. It's bigger than a lot of things.
And Phil, who's Mr. Sci-Fi guy sitting next to you?
That's Woody Allen in Sleeper.
This is Len Shaper. We'll be meeting him a little later on. He's a professor, and this is a big news here, right?
The biggest.
Really?
Nothing bigger.
No, sports is king.
Yeah, sports is king. He may be a professor and be doing very important things in the laboratory, but sport is king.
Laboratory.
The laboratory, as they say.
That's a Kiwi boy protective suit that he's wearing there.
And Gwen is at Quantico, Virginia, at the Marine Corps base. What's making news there, other than that you're the only person up, I guess? Fayetteville, Arkansas, at the University of Arkansas,
right.
And he's practicing safe reporting, clearly.
Right. Who gets to play the egg later
What's
on?
up, Phil?
Oh, I'm so clean, it's not funny. Let's have a look at these right here. This is a circuit board as we know it right now with a whole lot of chips on it, Tom. And what you can see on the right-hand side, the left-hand side of your screen, you can see what Len Shaper is holding here. This is a microchip module. It's a reduced form of this circuit board. And when we come back, we're going to show you the development of this. We're going to show you how to make one. And it has really revolutionized the way that will revolutionize the way that we make our electronic goods. One of the traditions that they have here after dressing up in the bunny suit, Tom, before entering the clean room, is to do the bunny hop. So Len and I are going to do that now for you. Let's do it.
We're all very proud of you, Phil.
That's right.
Thank you.
Well,
Now let's get the Gwen in the hokey pokey.
How's it looking back there, Tom?
I'm working on it.
Okay, all right. I'm getting 9 more microphones, scotch tape. Can we, wait a minute, guys, get the duct tape guys in here. Get the duct tape guys in here. Well, get them in here, because I need these things duct taped to my chest. University, which of course brings us the NCAA Final Four Razorbacks. But Phil, you're looking great today, I gotta say.
Well, thank you.
You look wonderful.
It's the new on-the-road wardrobe that they've given us.
There you go.
They don't want us to get any colds or anything, so, you know, they put us in this stuff. Tom, when you think of a circuit board, you probably think of this right here. I don't know if you've ever opened up your computer.
Think about it, why I fantasize about it, mister.
Well, you know what guys are like. They like to open up their electrical goods, and when you look inside, you see a circuit board like this one right here.
But I guess not. Okay.
Well, what we're going to talk about today is a new phenomena. This right here. This is a multi-chip module, and what it means is that information can go from one chip to another a lot faster. At the moment, it takes about 1/1000th of a second to go from here to here. And who's got 1/1000th of a second these days?
Yeah.
Well, certainly not Len over here, Len Shaper, who's one of the professors. What you've done is you've developed this new multi-chip module, and what does it mean?
Well, it means we're going to get the electronics in a package this size instead of that circuit board. And the ones we're doing here, instead of having to build 4 layers of metal, like the conventional ones over here, we only need to build 2 layers of metal. So that's going to make these things, which are pretty expensive these days, about half the cost.
Now, what that means, Tom, is obviously, you know, with a laptop computer, you're restricted with size because you need the keyboard and you need the screen. It means you can pack a lot more information into it. Let's have a look at how these things are made. First of all, we start with some silicon.
Start with a silicon wafer like that, and we're going to coat it first with a thin layer of aluminum. We're going to use that aluminum to make wires. Here's the machine we use to do the aluminum.
Now, what they do, Tom, is they put that layer of aluminum on right there, and then they come down to a room they call the yellow room, and the reason it's yellow is they want to cut out all the ultraviolet light. They take that disc and they put it on this machine over here, and I can see you got some purple goop. What does that do?
The purple goop really turns the surface of aluminum into film, so we can put an image on it. A
Okay, what they do over here, Tom, is they photocopy onto the goop. They use this photocopy type machine to give you the wiring systems, right, Lynn?
That's right. We can print a whole layer of wiring on here, and when we get done doing it, and then we wash away the aluminum we don't want, we come up with a layer of wires, just like that.
Now, Tom, just to talk about the wiring system here, come and have a look at this. This is a microscope, and it's showing a computer image right here of the wiring systems, and you can see going through the center of the screen right here is a hair follicle. So we're talking about very thin wiring. Now, if we take a walk down here, we do this process, they do the process once, Tom, to do the wires going one way, and then they do another process, and the same thing again where the wires go over the other. This is the 2 layers of wiring. And if you have a look at this right here, Tom, you can see that there are 8 little squares right here, so they can do 8 per disc. And what they do then is they cut these up. They've got to cut them up so that they can then place them onto the package.
Those shoots really should have tails, don't you think?
Into a machine, they cut it up right here, so we've got our individual little plates right here. Now you can see they're right here, and on the computer screen right here, you can see that they're about to put that multi-chip module disk onto the package system right here. Now what happens after that?
After that, we have to put the computer chips onto the multi-chip module substrate. It's done in the same kind of machine. And then we have to make some connections between the chips and the package, and the package and the substrate. And that's done in this machine over here.
Tom, are you confused yet?
Oh, no, Phil. We've got the whole transcript. We're just following right along.
I'm sorry,
Okay,
are you talking to us, Phil?
just stay with us. Okay. So this is what you're looking at right here. It's really it's like a small circuit board, just to put it in layman's terms.
Wow.
And Len, just let us know what the future holds for us.
Well, the future means that this kind of technology will give us electronics that's smaller, faster,
It's
and
Russell's
cheaper.
job.
And everybody loves that.
That's all you have to remember. Faster and cheaper.
Yeah.
Thank you, Phil.
Yeah. Hey.
Smaller, faster.
Patty Duke's here!
Yay!
Or is it Kathy Duke? By the way, all of our guests, Melissa, you'll get one too, get duct tape to call their hair.
Yes.
This is the most invaluable thing in the world. We should
Right,
have
guys?
used it on
Yeah.
our horse.
We have the duct tape kings right
Oh, they're the kings. Thank you very much.
Yeah.
You can also have a copy of. He's there. What are you doing this hour, Phil?
Well, Tom, this is the largest low-speed wind tunnel in the world, and if you come around the back here, you can see the 2 engines which generate the wind. And what we're going to show you when we come back is a simulated disaster of gas being released into the atmosphere.
Oh, great.
And yeah, except
guess
it's all
you've been in
contained, and
Tom's
you know it's
office,
pretty
huh?
topical right now with the whole thing that's happening in Japan. So we're going to discuss that and show you the research that they're doing here in order to avoid disaster.
All right, sounds good.
Yeah.
You know, this
All
is this is the largest felt wind tunnel in existence. Too. Gwen McGee is
of Arkansas. Phil, what have you got for us this hour?
Well, very interesting stuff. You know what happened in the subway in Japan recently with the release of the nerve gas, and
Yes.
the chemical release into the atmosphere could be absolutely disastrous. And some of the research that they're doing right here is predicting what happens when a chemical is released into the atmosphere. I'm with Tom Spicer, if you want to say hello there, Tom. And what we have right here on the computer screen is we have a mathematical representation of a smokestack and chemical, which you can see in purple there, being released. Now, the top shows us this top representation shows us a low wind speed. Could you explain what's happening?
Well, what this is a mathematical model of what we're going to be seeing in the wind tunnel later. This is the low wind speed case. The plume goes up because it's denser than air. It's got momentum and carries high. It falls back down to the ground. When you have the high wind speed case, it looks almost like a regular plume from a smokestack.
So, Laurie, you can see there coming out of the smokestack, and you can see the chemical being released, and it's being suspended because of the fact that the wind is carrying it along. It's denser than air, so it'll sink in a low wind speed, which is very bad. Now, that's a mathematical model, and it doesn't take into effect any obstacles. This is a computer representation of an obstacle, and can you explain to us what happens when that chemical hits it?
Well, this is a more complex model that takes into account the obstacles. As you can see here on the left, you're talking about the flow field with the obstacle. On the right, you've got the flow field with the gas present. And so you can see that the flow field is basically displaced by the gas.
So that's good, Laurie, to have high wind speed and to have obstacles. And you can see right here that the chemical is very concentrated right here. And Tom, this is good because it's dispersing.
Right. In this case, the obstacle creates additional dispersion.
Thanks very much, Tom. And if we come over here, Laurie, we can have a look. We have a wind tunnel set up. This is the largest low-speed wind tunnel in the world where they can do physical experiments. And I'm with Heather Walker right over here, who's the manager of this facility. And actually, what we'll do is we'll turn the lights down if we can. Thank you. And you can see now, Laurie,
wow.
that
Wow,
some
yeah.
CO2 is being released here, and it's coming up to a laser. How does this help you, Heather?
Well, it helps us to visualize the flow so that we can know what's going on with the turbulence and how the cloud's dispersing.
Okay, now, Laurie, what they can do is this is a 50-to-1 scale. And you can see, I'll get Z in position, you can see a stack right there.
Yeah.
What they're doing is they're releasing CO2, which is heavier than air, and you can see they're representing a wind speed of 20 miles an hour. If we reduce the wind speed, thank you, Laurie, what would happen with this high wind speed is it would go over the top of a city. You can see it's not resting down on the ground, and this is good, isn't it, Heather?
Oh, yeah, so now if there were a town located a little bit downwind of the stack, it really wouldn't be affected. The gas would go over it.
Okay, now, Laurie, what happens when this wind speed is reduced? You can see it's slowly starting to happen now. The gas is rising up, and what will happen is it will go up and then come down onto the ground, and this is representing a wind of about 5 miles an hour, which is not so good.
Right, and you can see it's already starting to touch down a little bit, and the turbulence characteristics are changing. And I'd also like to say the laser, the blue laser that you're seeing coming down, is monitoring the velocity, and that's hooked up to the computer so that we're able to monitor everything as it's happening. And you're seeing now it's really starting to slow down, and the turbulence is changing, especially in the far field. And now if there were a town located down there, that'd be right in the middle of the release.
And we all know what happened in Bhopal about 10 years ago, Laurie, when about 10,000 people were killed because of the release of a gas. What this does is this helps us understand how to prepare for an emergency if there is ever a chemical release. So it's very important work.
Fantastic.
Yeah,
Thank you
good
very
stuff,
much,
Phil.
Phil.
Yeah.
Tom?
Okay, thank you.
We had a little experiment here too, actually, Laurie, and that is how quickly will people act immature if you let them loose with moisturizer? And you can see how quickly that's happened. We've got more show coming up. Jim, tell us about it.
Well, before you date, are you making a list and checking it twice?